And so the first question of the end of unit test. A box contains 5 blue beads, 4 yellow beads and 3 purple beads. 3 beads are taken from the bag at random without replacement. And then you're asked 3 questions. Now a number of you will be able to work out these probabilities just by looking at the question and asking yourself, how many beads are there in total now? Okay, how many blue beads are there in this situation? And working systematically from there. If you cannot, a good way to visualise these problems is often through the use of a tree diagram. Now I've pre-drawn this tree diagram because it's quite a clunky one, but in essence, in order to fit everything onto a page, I'm starting at the right-hand side and drawing each of my possible outcomes and then working back to the left. If I work left to right, I find that I often get very bunched up and I can't really distinguish my branches. And so I need to look at the context of my question to fill in my probabilities. So I've got 5 blue, 4 yellow, 3 purple, so in total I've got 12 beads. So in my first round there are 5 out of 12 blue beads, there are 4 out of 12 yellow beads, and there are 3 out of 12 purple beads. And I could just check that my probabilities made sense by adding these 3 up and making sure they sum to 1, because there is a 100% probability of choosing either blue or yellow or purple. So if I've chosen 1 blue, then there are only 4 blues left out of 11 in total. There are 4 yellows left out of 11 in total, and there are 3 purples left out of 11 in total. If I've chosen 2 blues, then there are only 3 blues left out of 10 in total, but there are still 4 yellows left out of 11 in total, and there are still 3 purples out of 10 in total, 3 purples left out of 10 in total. Once again, checking all of these by making sure they add to 1. If I've taken a blue and then a yellow, then I have 4 blues out of 10 total, I have 3 yellows out of 10 total, and I have 3 purples out of 10 total. If I've taken a blue and a purple, I have 4 purples out of 10 total, I have 4 yellows out of 10 total, and 2 purples out of 10 total. I'm going to do the same thing again. If I've taken 1 yellow, then taking a blue would be 5 out of 11. I've got 3 out of 11, and I've got 3 out of 11. Once again, they add to 1. And then yellow and a blue gives me 4 out of 10, 3 out of 10, 3 out of 10. 2 yellows, and then the blue would therefore, I've still got 5 out of 10. The yellow would be 2 out of 10, the purple 3 out of 10. Same principle here, yellow then purple. I've got 5 out of 10, I've got 3 out of 10, and I've got 2 out of 10, adding to 1. And then my final set of branches, purple, so to get a blue would be 5 out of 11, to get a yellow would be 4 out of 11, to get a purple would be 2 out of 11, checking my addition again. Purple, blue, so to get another blue, would be 4 out of 10, and then 4 out of 10, 2 out of 10. Purple, then a yellow, would be 5 out of 10, and then 3 out of 10, and 2 out of 10. Purple, then purple, would be 5 out of 10, 4 out of 10, and 1 out of 10. As I say, you don't necessarily need to draw this out, but it helps me to visualise the problem. And then part A, what is the probability of picking in order blue, yellow, and then purple, in that order? So that is choosing a blue, then choosing a yellow, then choosing a purple. And there's only one branch that can provide that, because it is very much asking me in this question that order: blue, then yellow, then purple, no other order. So I'm doing blue and yellow and purple, so I multiply my probabilities. So I have 5 twelfths times 4 elevenths times 3 tenths. I could just cancel and simplify, so let's do that actually. So 4 times 3 is 12, and then 5 over 10 is a half, and so I'm left with 1 over 22. Part B, work out the probability that all 3 beads will be the same colour. So in my probability tree, that's either blue, 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 or yellow, 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 or purple, purple, purple. So once again, going along my branches, I multiply. So blue, blue, blue would be 5/12 times 4/11 times 3/10. Or it could be yellow, 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 so I have to add the probability of yellow, yellow, yellow. 4/12 times 3/11 times 2/10. Or, so I add again, purple, 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 which is 3/12 times 2/11 times 1/10. I'm just going to type that for quickness into my calculator. 5/12 times 4/11 times 3/10 plus 4/12 times 3/11 times 2/10 plus, and then I've got 3/12 times 2/11 times 1/10. I'm just going to write that as 0.1. My calculator's running out of space, which gives me 3/44. Now once again, lots of quick ways to do that. You could notice that everything's over the same denominator, 12 times 11 times 10. So you're just doing 5 times 4 times 3, 60, plus 4 times 3 times 2, 24, plus 3 times 2 times 1, 6, all over 12 times 11 times 10, and you could work from there. But when you have a calculator, why not use it? And so part C, what's the probability that the three beads will not be the same colour? You know that either they can all be the same colour or they will not be the same colour, and those probabilities must add up to 1. So the probability of not being the same colour is 1, subtract the probability they are all the same colour, 3 out of 44, which is 41 out of 44. And that's question 1, quite involved, sorted.